This is Geometry, Chapter 9, Lesson 1 on page 338. All right. So how do you think they calculate the land area of the United States of America?
I have no
They
idea.
find out each state and then they just add it.
Okay. That's a great idea. Yeah, yes?
They can find like they can basically not make it into a square, but they can like draw a square around it and then like subtract the parts that
Yeah, so they divide it up into smaller regions, right? And then add it up. It's actually calculus here because there are curves. And so when you get calculus, you can find the area under a curve. It's using math. But they do divide it into smaller regions, such that the entire area of the United States, you would have to add the areas of all of those smaller regions to get the total area, right? You agree? Yeah, okay. That's the way it is with any figure. It's called a polygonal region. Look on page 339. You see that word? Polygonal. Looks like polygonal. It's pronounced polygonal. Polygonal. You can say it however you want to, because you know I do that with words as well. It's polygonal, a polygonal region. So the area of any polygonal region is the sum of its individual areas if you divide it up. Okay, you did a lot of this in Algebra 1, maybe. Maybe.
Probably not.
Okay, I have two images that are very much like what would have been in your Algebra 1 textbook. What type of polygons do you see in this first image? What do you see? What do you see, Selby?
Triangle, rectangle, semicircle.
There we go. We have a triangle. We have a rectangle. We have a semicircle. So the area of this entire polygonal region would be the area of the triangle plus, that means area. Okay. Area of the rectangle plus the area of the semicircle.
That's the Jesus fish.
Got it? Yes.
Praise the Lord.
All right, so you have to add all the areas. So we have to figure out the area of each one. Can we calculate the area of the triangle? What is it, Elliot?
it would be 6.
How'd you get that?
Well, the 13 is like the length of the whole thing, but you subtract it by 10. So it's 3 times 4, but then you have to divide it by 12. Wait, divide it by 2.
Got it? You see how he got the 3? He took the 13 of this entire length, subtracted the 10 at the top to make that 3. So it's 1/2 times 3 times 4. So 1/2, 3 times 4, which gives us 6. Got it? All right, what about the rectangle? What's the area of the rectangle? 40. How'd you get that, Landry?
Multiplied 4 by 10.
4 by 10. So it's 40. What about the semicircle? Yes, Chris?
We're gonna put the 4 and then we're gonna, isn't the radius?
Yes.
No.
What's the formula for area of a circle? How many
Pi
dimensions
squared.
is area? How many dimensions is area? 2. What is it, David?
Pi r squared.
Pi r squared. That's for a whole circle. What about for a half of a circle? A semicircle?
Pi r squared divided by 2.
It's half
Pi r squared.
times pi. What's r?
Radius.
What is r? What is the radius?
4. No, 2. Gosh. 2.
The radius is 2 because it's half of the diameter. So 2 squared, which is 1/2 times 4 pi, which is,
Counting the wrong answer.
what's 1/2 times 4 pi? How many pies? 2 pies. In my
46.
class,
Chocolate and
3.14. Please say 3.14.
we are not going to use 3.14.
Yes.
No, No, never. You leave
It's
pi
so
as
much
pi.
Well, actually, I'm fine
Yes.
with
So
that.
much
I'm fine with
easier.
that.
Yay.
So you add 6 and 40, so that's 46 plus 2 pi, whatever the measurement is, centimeters, whatever it is. In my class, you leave pi as pi. If you put 3.14,
I won't, I swear.
She will find where you live and she will understand recording.
that's right.
Not cry.
I control your grade.
You scare me
Are we
a
doing
lot.
Friday?
You want anything Friday?
No, Pi Day.
No.
Pi day!
Can we please?
March 14th.
Mr.
I'll
Wolford
bring
never brought us
I'll bring a
anything.
pie.
I
I'll
told
bring
him.
a pie.
Okay, we'll talk about that after we finish, okay? All right. All right, can we figure out the area of this region?
Yes.
Oh, really?
I know.
Let's do it!
I know.
Okay, where are you gonna divide it up at?
It's 40, or the right side is 40.
What right side? This side?
But like, yeah, it's 40.
I don't think this is 40.
Wait.
What?
Oh,
the-
no, it's 10.
It's
you were
10.
on- You were on.
Wait,
something
It's 10 and then
No,
the
no,
other
not that
one is
side.
7.
Okay,
No,
All right.
The other one is
So
7.
the rectangle right there on the right side. So
He
let's
cut
say,
off.
let's say you put a line up from where the 5 is.
He cut off part
Yeah,
of it.
right
and
there.
made his-
That's
yeah,
40.
that's how we learned to do it.
Yeah, that's how, yeah.
So like, you just set it up into 3 sections.
okay, yeah. Okay, good. Okay,
Then you can do
It's
put a line up from the 8.
40. Is 40 again?
up from the 8.
It's 40.
40.
Up from the 8. So if you like draw a line.
You think here?
That's 40 also. And then that side is just.
How do you know that's 40?
Because
Wait.
8, it's gonna be 8 minus 4.
Where'd you
no.
get the 4 from?
No, what I did is I split the
Well,
I,
four
I
at the
split the
bottom.
10.
Yeah.
Can we split
Yeah,
the
go
10?
from
Yeah,
seven.
like that, and that's 40.
Yeah, that's much better. This is 8 by 5, which is 40. Can you figure that one out?
Yeah.
That's 5 times 5 is 25.
How do you know it's 5?
Wait, no.
Well, because if the other side's 5 and it's 10.
Yep, you can't know this top, can you?
Yeah, but
Oh,
it's-
you know the top.
How do we?
Oh, yeah, you can.
Yeah.
Oh, okay, tell me how.
If she says you can't, please.
It's
I know the whole bottom is 8, but I don't know what portion of the 8 that top is.
7.
you can guess.
Yes.
You can't because you have to have this.
4, 5.
We don't know that.
So it's just
So we would have, this would
5x.
have to be given, if that's 3. That
Just
could be
5x.
3. That would be 15, right? And then you'd add them up. You have to know this. I wanted you to get to a place where you couldn't actually figure it out.
Oh boy.
But you thought you could initially, didn't you? But you
Right.
couldn't figure out that one piece of the puzzle. I could have given you something all the way across here. Sometimes they do. That wouldn't
What would
have
that
helped.
do?
That would not have helped. Unless I did it to here. Which would be 12 minus 3, 11. If I did that, then you should be able to know that.
12 minus.
Or if I did this, 11. I could have given you that one.
Wait,
Then
wait,
you would have known that
12
was 3. Do you see that?
Wait, if you add up 3 and 11.
3, no.
Oh my god.
12
Yeah, okay,
minus
sorry.
3, 9. This would have to be 9.
Yeah.
That would work, yes. I meant 9. Then you could have done it. Does that make sense? Okay, so that's what this whole lesson is about. It's the area postulate. Look on page 339. Every polygonal region has a positive number called its area, such that congruent triangles have equal areas. Did you know that? If two triangles are any, it doesn't matter what the shape is. If two polygons are congruent, then their areas are equal. And the area of a polygonal region is equal to the sum of the areas of its non-overlapping parts. The parts cannot overlap. You know what overlapping is? It would be sort of like if I then told you this was 4. That couldn't be right, huh? There'd have to be an overlapping part if I told you that was 4. Does that make sense? All right, then they go on. No, that's in a different lesson. Actually, there's this crazy concept, the way that they calculated the area of pyramids. They were close, but didn't get exact. That's this entire lesson.